Welcome back. Today we're going to talk about our day 2 notes and our right triangle trigonometry unit. But today we're going to talk about word problems. So you're definitely going to need your graphing calculator today. And what we're going to do is we're just going to basically do exactly what we did last lesson, except this time we have a picture and we have maybe a context to it. So the first one we have is we have a guy wire. So one of those wires that's holding up this pole here on the top of a 120-meter pole, right? We're going to assume that that's perpendicular to the ground. It makes a 68-degree angle with the ground, and I want to know what is the length of my guy wire. So the first thing we want to think about is what are our trigonometry ratios? So remember last time we talked about SOHCAHTOA, right? So we have the sine is the opposite of the hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite over adjacent. So if I look at my 68 degrees here, I've got this side over here. This is my opposite side of the triangle. This right here is my hypotenuse. So opposite and hypotenuse is going to tell me I'm using the sine function. So I have sine of 68 degrees equals my opposite side over my hypotenuse. I want to cross multiply. So I have 120 equals x times the sine of 68. And we're trying to get x alone here. So we're going to divide by the sine of 68, divide by the sine of 68, cross those out. So now I'm going to go over to my calculator. And first thing I want to do is I want to make sure that my mode is in degree mode. All right, so I need to change that to degree mode. Now I'm ready to start. And so I've got 120 divided by the sine of 68 degrees. That gives me 129.4241. We want that to the final length of the guy wire. So I actually want that whole number there. So 120 divided by the sine of 68. Oh. Oh, there we go. So I've got 129.42416191. Doesn't tell me exactly how to round that, so I'm going to leave that whole number to the nearest meter. All right, number 2. In rectangle ABCD, so I'm going to draw my own rectangle. I'm going to label my vertices. Remember going around and it says diagonal AC is 11, side AB is 7. Find the measure of angle CAB to the nearest degree. So I'm looking at this right triangle right here, right? Because I know that a rectangle has a right angle. And if this is my reference angle here, I need to now again label. I've got SOHCAHTOA. And I know right here, I know I have a hypotenuse. This side here is my adjacent. So adjacent, hypotenuse, that's a cosine function. So cosine of x equals my adjacent over my hypotenuse. So now this is where on my calculator, I'm going to use my second cosine function, 7 over 11. This one did say the nearest degree. It's going to be about 50 degrees. So the measure of angle CAB is approximately 50 degrees. All right, number 3. We're given a square. Okay, so square ABCD, side length is 8. And I want the length of diagonal AC, and I want this in simplest radical form. All right, so now this one here, I want in simplest radical form. So I know that this is also 8 because I have a square. So in actuality, I'm not going to use trigonometry at all. I'm going to use my Pythagorean theorem. So a squared plus b squared equals c squared. 8 squared plus 8 squared equals my x squared. So 64, 64. Here's 128. Now, when I take the square root of this, I notice right here I've got 64 times 2. So this is radical 64, radical 2. So 8 radical 2 is equal to my length AC. All right. Now we're going to talk about a little bit of new vocabulary. So we're going to talk about two things, our angle of elevation and our angle of depression. So at a point on the ground 40 meters from the foot of a tree. All right, so here's my very artistic tree. We have a point 40 meters away on the ground. And I've got the top of the tree here. And what I'm thinking is my angle of elevation is if I'm starting down here and I'm looking up at that tree, that my 42 degrees is here. And I'm looking for the height of the tree. So this is something pretty common. I might not know how tall a tree is. So what I can do is I can use a protractor. I can use my cell phone even. And I can move a specific distance away from that tree to try to find my unknown. So my angle of elevation is that angle right down there. Okay, so same thing as I did before. So SOHCAHTOA. And I look at the sides that I have. I have my adjacent side. I have my opposite side. That's going to tell me that I'm using tangent. So this is the tangent of 42 degrees is my opposite over my adjacent. I'm going to cross multiply there. I do want to always put this one first so that my angle and my side length don't get confused or combined. So 40. No. All right, technical difficulty here. Let's see if we can get that open again. Okay, so I've got 40 times the tangent of 42. I'm just going to put that in my calculator that I've got here. 36 nearest meter. So about 36 meters. All right, number 5. From an airplane that's flying at an altitude of 4,000 feet. So here's my airplane. And I'm flying at an altitude of 4,000 feet. Now, when my airplane is flying, this is my view from the airplane going straight across the sky. When it looks down at the airport, this is now my 29 degrees. So this is what we refer to as my angle of depression. Okay, and my altitude's gonna make a right angle with the ground. Now, one thing you want to notice is that my sight line for the plane, my ground, we're going to assume are parallel. Since we assume that they're parallel, we have alternate interior angles here. I am looking for the distance between the airplane and the signal. So I'm looking for this right here. So again, thinking of SOHCAHTOA, I have a hypotenuse, my reference angle here. I have an opposite. Opposite and hypotenuse is my sine. So the sine of 29 degrees is my opposite over my hypotenuse. So I'm going to cross multiply. So x times the sine of 29 equals 4,000. Let's get that x alone. All right. Let's see if we can log in that calculator again. Oh, it's coming back. So 4,000 divided by the sine of 29. All right, so my x to the nearest 100 feet. So I had 8250.661359 to the nearest 100 feet. Nearest 100 would be about 8,300 feet. All right, number 6. Find the nearest degree, the angle of elevation of the sun. All right, so we have a pole that's 6 meters high. We've got the sun. And when it casts its shadow is going to be on the ground, and that shadow is 8 meters long. So if I think about where my shadow ends, my angle of elevation here, right, is what's going to get me up to the sun. So again, thinking of SOHCAHTOA. This is my reference angle. I have my adjacent side. I have my opposite side. That tells me I have tangent function. So the tangent of x equals my opposite over my adjacent. So this is where on my calculator I'm using second tangent. So notice I'm only using second tangent if I'm looking for an angle. And I want this to the nearest degree. So I've got about 37 degrees. Okay, number 7. From a point on the ground 25 feet from the foot of a tree. So here's my tree, 25 feet away. The angle of elevation of the top of the tree, 32 degrees. I'm looking for the height of the tree. Okay, thinking about SOHCAHTOA again. So I have my opposite, I have my adjacent. That's going to tell me I'm using tangent again. Tangent's a very common function to be using. So the tangent of 32 is my opposite over my adjacent. Cross multiplying. So 25 times the tangent of 32. Times 15.6, and I want this is the nearest foot, so it's about 16 feet. All right, number 8. A fisherman observes that the angle of elevation from the top of a 120-foot lighthouse to a boat, so I got my little boat out here, is 6 degrees. I want to know, since I know that my lighthouse is 120 feet, I want to know how far is my boat from the lighthouse. So, same as last time. SOHCAHTOA. I have an adjacent. I have an opposite. That's a tangent function. So the tangent of 6 degrees is my opposite over my adjacent. So cross multiply. 120 equals x times the tangent of 6. Let's get that alone. So 120 over the tangent of 6. 1,141. Nearest tenth, 1,141.7. And we're in feet here. All right, number 9. Mike Patterson looks out the window of his attic of his home, which is 22 feet above the ground. At an angle of elevation of 35 degrees, he sees a bird sitting at the top of a very large high-rise apartment building down the street. How tall is the high-rise building if the two buildings are 75 feet apart? All right, so I do have to think about a couple of things here. I do know the height of this building is 22 feet. So when I find my x value here, whatever I get, I'm going to add 22 feet to that. So thinking about SOHCAHTOA. I have my adjacent side. I have my opposite side. This is a tangent function. So the tangent of 35, opposite over adjacent. So let's cross multiply. 75 times the tangent of 35. 75 times the tangent of 35. Okay, so we've got 55.51556537. We're going to add 22 feet to that. And so it doesn't say where to round on this problem. So my height, let's not use x again. So my height, got 74.51556537 feet. All right, we're all set with day 2. Good luck on the homework and let me know if you have any questions.